I've got the dueling sensors going here. The Hall effect sensor back here. It's a magnet. I have the opto sensor here. I put black tape on my spindle so it makes a better optical sensor, optical obstacle. And I've got the magnet taped underneath here. I've got display divided up into two sections, 2 digits for the photo interrupter and 2 digits for the Hall effect. The photo interrupter sees 2 interruptions per rotation because it sees both sides of this rotor, and the Hall effect sensor just sees one since there's a magnet on one side. This one's divided by 2. I count for 6 seconds and display the 6-second count. So this is exactly RPMs divided by 10. So the first 2 digits of RPMs. Let's fire it up, see what happens. So we won't see anything until the first gate interval of 6 seconds. See, we've got 13 or 130 RPM. Actually, that's 190. It's a little bit hard to read this in a bright light. And so when we get 1 count more or 1 count less in a 6-second interval, we end up seeing either a difference between them or a match. And that is just arbitrary. If we increase the averaging interval, we'll get more. And that effect will get less and less, and it'll take 6 seconds for this to zero. So there was some of them out of the interval there, and it'll go to 0 in another 6. Okay. Let's goof around a little bit. Turn this thing all the way up. Okay. It's about as fast as this drill motor will go. It's a 9-volt motor, so 740 RPM. About as slow as it'll go. It's probably going to end up being about 50 or something like that. See where it goes. So there's all kinds of counting algorithms we can use to try to smooth it and filter it and find it, look at responses quickly. And if all that's important, then that software can be added. That's all software. This looks like 70 RPM. Let's see how slow we can go. Okay. So it looks like we can get to about 20 before the motor stalls. So let me take the camera off tripod and see how this looks from different angles. And so there's the optical interrupter going, nothing very spectacular. And there's the Hall effect. And the connectors. So I made a little Y connector on the power so that I can power 2 sensors instead of just one. Again, this is, you're probably not going to really do this. There's the connector that comes out. The pink one is the Hall effect and the white one is the optical one. These are what you're used to seeing, the 10th inch headers. I put the red shield on so it looks a little better. And then maybe I've got a bright enough light that you can see into here now. See what these connectors look like. And then the yellow cable lines up with the yellow dot, and over here the blue with the yellow dot with the little bit of blue scratched on top of it. So there's our dueling sensors, and every now and again, so our 1 second interval is not exactly synchronized with when that thing swings around, which is the reason that occasionally one will count and the other one won't, because the clock might decide to tick when we're halfway in between and we're about to get the next one. Okay, I'm going to push this code to GitHub. It's called Hall effect versus Photo Interupter in the subdirectory.